Happy Sunday, everybody. Man, I'm pretty tired, especially for a Sunday. But we'll get on with the show. Last time, I was so brain dead by the end, and I was working through an HL paper, of all things. But this should be a smoother ride. SL, I can do any day, anytime, and probably get a good mark on this. But we are going to continue with the second half of the exam, which would be a paper 2, and that's their calculator section. My favorite. Oh well, I have a feeling this might be a pretty chill stream, or it could be really bad, because I do know Jazz has an assignment due, so she'll be popping up probably. Alright, let's see. We have a group of 35 students. Some are in the art class, some are in the music class, 5 don't take either, and then all of this is in a handy dandy Venn diagram. So, write down the people that take the art class. Okay, that's easy. That's the people in this circle. So, 17. One student is chosen at random. Find the probability that the student does not take an art class. So the people that don't take an art class are these groups of people. That's 18. So the probability of choosing one of those is 18 out of however many there were total. 35. And I don't think you can reduce this, but I don't think it matters, to be honest. Okay, and then the student takes either the art class or the music class, but not both. So art class or music class, but not both. So 11 plus 13. What is 11 plus 13? 24? 24 out of 35. Okay, not bad. I don't see why this is in a calculator section. I can see why this one's definitely in a calculator section. I feel like every paper 2 has a linear regression because it's the only time when you can ask one. Okay, we're gonna relate hand length to the height of a person. Hold on, did I do this paper already? Uh-oh, I think I did this paper already. Shoot, I gotta find a different paper. At least I'm only one question in. Abort. Let's go to May 2018. But I still want a paper 2. Oh, gotta change my name too. This is May 2018. How did I do a paper 2 before a paper 1? Oh well. Okay, from the start again. We have a vector question. This is no longer part of the curriculum, so I'm gonna skip that one. And then let's just jump into number 2. So I guess it kind of balances out. I did a number 1, and then now I'm on to number 2. Okay. So we have this graph here, and then we need to find the integral. This is the indefinite integral, and then find the area, blah blah blah, between 1 and 2. Okay, So this will be a non-calculator part in part A because you're just finding an indefinite integral. This should be pretty straightforward. You can use your formula book or just reason it out. But either way, you should get this as an integral. You can always check your answer too. Take the derivative of this one and you should get this one. Don't forget your plus c. You lose a point for that, I think. And then thus find the area enclosed by the graph of f, the x-axis, and the lines 1 to 2. So find this area. So we can just do an integral. You don't... You can just plug in the values if you want to. You can use a graphing calculator if you want to. I'm going to use a graphing calculator. I'm not going to use a TI though. Just use Desmos because it's a little faster. So the integral from 1 to 2 of our function, what was it? 6x squared minus 3x dx. Yeah. And that's just 9.5. Okay, what's next? A data set has n items. And then you add up all the items, and then it's going to be 800 together. And then the average mean is 20. So find n. So this is easy enough, right? Because if you take the sum of all of them, and then you divide by how many there are, which is n, this should give you the mean. So in other words, n is 800 over 20, which is what, 40? Then the standard deviation of this data set is 3. What we do is we multiply the set by 10, then we need to find the new mean and the value of the new variance. So the mean is easy enough because you just take the old mean, which is 20, and you multiply it by 10. So that's 200. If you want to find out the value of the new variance, this stuff you don't actually need to memorize. It is in your formula booklet. So if you go down to statistics, I'm fairly sure it's in your formula booklet. Right here. So let me zoom in. So essentially, the variance after you multiply by something, hello, is today the day. So the old variance, to calculate the new variance, it's the old variance times whatever you're multiplying squared. We need to calculate the old variance first. So old variance is the standard deviation squared, the old one. So then the new variance is the factor of 10 squared times the old variance, which is standard deviation of 3 squared. So this is 9 times 100, right? So 900. Did you just start the assignment, Jazz? Using laws of logs, write the expression as... Oh, this is easy. Just use your log laws. Make sure that you use them properly, though. Okay, what do we got? We got a circle with an angle, radius, sector... Wait, points A, B are on the circumference, yada yada yada. The area of this is 12. And the arc length is 6. Probably need to find the value of r and theta. Just r. Do you want me to help you with that one? Or are you just posting it? Your answer doesn't have the same domain. So what do you got? Natural log? Square root of x minus 3 What are we square rooting? Like the entire thing is square rooted? Okay. So you have... You have this, right? Okay. So just use your things one at a time. First thing is that square root you should write as an exponent. There's a square root in here. Like a square root inside a square root. Or are you just saying this is included in the big square root? I'm good now? And then you just make sure you use your rules, you know, one thing at a time. And make sure you keep brackets so that everything stays organized. So what's first? We should deal with this, right? So this is 1/2 and then all of this stuff. And then next up is the division. So then you're going to split this into a subtraction. And then you just have to be careful with the 1/2 coefficient. And then you keep going. Then you do this one, and then you do this one, and then that's all you can do because there's no laws about adding and subtracting inside the logs. And then that's all you can do. And then I don't know if they want you to simplify, to be honest. You did that? And you got 15, 17, but it's wrong? But no logs of products, quotients, or powers. Really? That looks right to me. Wait, oh, okay, this is 34. Your domain doesn't match the other one? These should be the same. Hint. It says square root u2 is absolute value u. Okay. Oh, I guess you have to be a little careful and then maybe add these absolute values in. And then try this out. Yeah. So what they do is they simplify the exponents first, and then they basically distribute this 1/2 into the exponents before they split them. And then they do it this way because then it's easier to remember when you square root something and then the square root cancels out because there's like a square. It's not necessarily just like whatever's there. For example, this is not actually equal to x. You need to consider it's actually equal to the positive version of x. So when they apply that in, then what they have instead is they have this absolute value of a to the power of 15, and then absolute value of the bottom one to the power of 17. Yeah. And then they use their log laws to split it up. And then if you bring down the 1/2 early, then you don't see that. Yeah, it's a small detail. Natural logs. Okay, so this one's back to this question. We're given the area, we're given the arc length, we have two variables and we want to find one of them. No, it's like Latin, like logarithmus naturalis or something. Actually, I'm just making that up, but I feel like that's a plausible answer. Anyways, this is very clearly a system. Well, that's because, you know, scientific names of plants and animals are Latin. I don't know. Let's Google this. Why is natural log ln? Wikipedia. You know, I feel like... Wait, am I right it's Latin? I didn't see it in the Wikipedia. Sweet. I knew that was probably why. Or you could say, like, you know, normally it's like log base 2, for example. Well, technically it's log base the natural number, which is e. So then I guess they just take the L and the N if you want to think about it that way. But then it goes in this order if you say it that way. Log base e. But Latin sounds good. We'll stick with the Latin one. Okay, back to this one. So the area is 12, and then this formula is pretty straightforward. It's in your formula book. It's 1/2 theta times r squared. And then we have the arc length. This is 6, and then this is just theta times r. Find this derivative. That's a crazy looking derivative. Because you have natural log x and you have secant x. That's a little problematic. Did they teach you any, like, special techniques? Derivatives of logs and inverse trig. Can't find anything about secant, only blah 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 blah. Okay, let's see. Derivative of natural log x to the power of secant. So let's see stack exchange. Okay, do you know implicit differentiation at this point in time? Because that's probably how I would do it. You do? Okay. Okay, so we have y, and then natural log. And honestly, I don't know if this is going to be the right way to do it. But what we can do is, this is the issue. We have in a variable x in the base, and we have a variable x in the exponent. And there's not really a nice way to derive that. Like, there's no rules for it. But that's part of the reason why you learn logs, is we can take things out of the exponent. The issue here is you can't take it out because it's not x to the power secant like this. You're taking the entire log and taking the exponent. Well, that's fine. We can just turn it into a log. So what we do is we log both sides. Natural log. So now I can take this out of this new natural log that I have. And then from here, you know, you're going to use a little bit of implicit differentiation, and then on the left side, and then on the right side you use a product rule with a chain rule. And I think you know the derivative of secant x, probably. So now we take the derivative of everything. So on the left side, you get 1 over y, and then you chain rule with y prime, and then you figure out the left side, and then you isolate for y prime. So go from there, and then let me know how it goes. Okay, back to this one. So there's so many ways that you can solve this system. Oh, Anita, you need help with a question? The algebra. Okay. You can type it if you want to. Or if it's annoying to type. Oh, sure, you can upload to Imgur. You can also join my Discord, and then you can post the image in the math help channel next time. What the heck is all of this? There's 2 pictures. What's the... This is the answer, right? And then we're just trying to explain it? Okay, whatever. Let's see. Use the definition of a log to write the equation in exponential form and apply properties of exponents. So this thing, I'm just going to copy this. So, I don't know, you get this formula from somewhere, and then we have this exponent, and then first, because it's an addition, we can split it up into 2 different exponents. And then because we have an absolute value, then that means that there's actually 2 different equations. That's what this is saying here. Either this thing is positive, which means that we just have like this equals this, which is the first statement, or this one is negative. If that's the case, then this thing is actually equal to the negative version of this, and then this negative will cancel out with this negative, which makes it positive. So that's, you know, absolute value stuff that you should be comfortable with by now. So you get 2 different equations, and then let's see, e to the power g, well, these are constants, same with negative e to the power g. Then you can just replace them with m, and then m includes the negative in it, if that's the case. It doesn't really matter. There's no difference between m and negative m. And then you can just say this instead, because m is a variable. It can be negative, it can be positive. So that's why there's no negative there. It doesn't matter. It's part of the variable. So you don't need to say it. And then from there you can solve the equation for w. Because m will be whatever it needs to be. So yeah, you don't need to put a negative in front of a variable. Yeah, it can be both. Okay, back to this system. There's lots of ways you can do it. I want to show you guys a semi-big brain way. So, you know, you would probably like isolate for theta or r, and then you would substitute it in. But notice we have theta times r. And in this equation here, we also have a theta times r. So instead of doing this one variable substitution, then we can just do a entire substitution. So I'm going to write this out explicitly so you guys can see what I mean. But theta times r squared you can write as theta times r times another r, not r squared. You got it? Nice. And then I know that all of this is actually 6. So then we have this equation for r. I'll write here. 12 is equal to 1/2 times 6 is 3. So 3r. So r has to be 4. And then we're done. 3. You have to be careful how you type that. What has the other power of x? Is it the 3? Or is it the x to the power of 3? You need to put more brackets in there, Jazz. Because there's a difference between this and between this. Second one. It's a very similar process as the last one we did. You know, you can't have x to another power of x, so then you should log both sides and then take down the exponent and then go from there. And do you know how to take the derivative of, you know, something to the power of x? I feel like that's something that they should have taught you. Because you'll need that for the product rule. Shouldn't what? No. Because you just, the m like absorbs it, because m just represents any number, whatever works. So you just replace the old m with the new m, which includes the division. Because it's all constants anyways. Also, when taking down the exponent on the right side, you take the entire thing. You take the entire thing. Oh, okay. Function transformations. Something that should be simple, and yet somehow my class, which just had a test on this, did not do so great on. Transformations are so easy. Okay, here's a function. Then we need to sketch this graph. So all you need to do is be able to identify what transformation this is. And then this is a reflection across the y-axis. So let's take a few key points, which are these three. And then they will be reflected across the y-axis. So this one goes all the way over here. This one is going to get reflected over there. And then the one that's on the y-axis will stay where it is, and then you connect your dots again. Easy peasy. See? 2 marks only. Shouldn't take you too much time. However, there is a part 2. Okay, so we have another function g, and what it is it's two transformations, and then here's g, and then we need to find the value of a and b. Okay, so first, let me just write the original function so that I have something to compare it to. So the original function looks like this. Okay, and they do give you some hints about what you need to do. First thing is there's only two transformations, and from how they're formatted and written, we have here a reflection, across the x-axis, and slash or vertical stretching. And then this one is a shift, horizontal translation. So there's only two transformations to keep an eye out. Obviously we do have a reflection because now it's upside down. So A is definitely negative. And then we need to find out if our graph has been stretched in any sort of manner. So let's first flip this. Okay, and then you can see that there is a vertical stretch as well, because the total vertical height of this is 2 squares compared to g, which is a total vertical height of 4. So we do have a vertical stretch of a factor of 2, so a is negative 2. And then b is the shift towards the left. So it moves over one space. Now you have to be quite careful with this one just because they're being mean to you. Blake the Cake, thanks. The way they've written it, it already has a plus. So if we want to move things to the right side, then this should say minus. So b is more than just 1, it's negative 1. And then traditionally it's not written this way because the format, the general form of transformations, vertical translations, is with a minus. So they're just being mean to you. Okay, you don't know how to take the derivative of 3x. So this is something that you'll eventually commit to memory, but let's you need to do this on the side. So let's say you're trying to find out what the derivative of this is, right? You have to do the exact same process. So you take the natural log of both sides. So then you can take down the x. And then when we take the derivative, you get 1 over y. And then you multiply both sides by y, so then you'll have like x natural log 3 times y. And then you just make a substitution. So this becomes x natural log 3 times 3 to the power of x Oh, oops, I forgot to take the derivative of the right side. When you take the derivative of the right side, you just keep the constant, right? Which is natural log 3. So here's your derivative. And then the 3 is, it doesn't even matter what number that was. So depending on the course, they'll actually just tell you to memorize this. But if you're the derivative of like a to the power of x, you can just memorize this. This is just natural log a times a to the power of x again. So yeah, whether or not they want you to memorize that or they want you to go through this process every single time, I don't know, it depends on the course. But there you go, that's the derivative. And then you just, product rule that stuff for the actual question. This doesn't really feel like a paper 2. I think I've only used the calculator once or twice so far. Do I have to do chain rule for this? Well, when you take the natural log, you bring down the exponent. So then what you're left with is 3 to the power x times natural log x. There's no chain rule needed for each one of these. You just use the product rule. Okay, what do we got? We have some quadratic, and then it has p's and q's. And then find the number of roots for this equation equaling 0. And then you justify your answer. Okay, so the number of roots is related to the discriminant. So if we follow the discriminant, which is just b squared minus 4ac, which is just a part of the quadratic formula. If it's negative, you don't have real solutions. If it's 0, then you have one real solution, and then if it's positive, then it has 2 real solutions. So that will tell us how many roots we have. So here's my a, which is p, here's my b, which is q, and then this entire negative 4p is my c. So just plug it in and then we'll just see what happens. So we have q squared minus 4 times p times minus 4p. Okay, so what do we got? We got q squared minus or plus 16p squared. Okay. And then now we need to determine whether, this thing is negative, 0, or positive. And you might be asking yourself, well, how do I know that? Because I don't even know what any of these things are. Well, I can tell you right now, you need to remember that when you square variables, they're either 0 or positive. So this is either 0 or positive. And then 16 is 16, and we're adding 16 times something. And then let's look at p. P has to be positive. And the reason why it's not 0 is because they tell you right here p can't be 0. So regardless of whether p is positive or negative, when you square it, it's going to be positive. Q can be 0 for all we care, it doesn't matter. But let's look at this total result, right? You have something that could be 0 or positive, and then you're adding another positive number to it. So regardless, this will have to be positive no matter what. So we know that there have to be two real roots, two real distinct roots. Okay, what do we got? An arithmetic sequence has the first term is log base c of p, and then the second one's log base p q, and then c is the base, so it needs to be larger than 1, and p and q have to be positive, sure. And then we need to show this d. Okay, so this is easy enough to do. There's lots of ways you can show this, but you know, the most basic way is your common difference should be u2 minus u1, or you subtract any two consecutive terms in your sequence, and then that should be the common difference. And then from there we can just use log rules, because we know that this u2 is pq, and then we subtract u1, which is just log cp. And then we can use log rules. So we have a subtraction of two logs of the same base, so then we can divide them inside a single log. And then because p isn't 0, they tell you it's not 0, these cancel out. So then there you go. You've shown that the difference is just log CQ. You should be able to do that integral by yourself. There's nothing super complicated about that one. The reciprocal one, you just change it into a not reciprocal one. Just write it as x to the power of something. I don't know, are you typing it in right? It's just this, right? Are you remembering your constant? What do you mean no? What, is this entire thing in the denominator? Oh. No, then you should type it that way. Do you know partial fractions? Yeah, well, okay. 4x plus 14? Are you sure you copied the question down right? It becomes this. Is that a hint? So according to you, you complete the square. So what we get is we get, you know, something a little nicer down below because now we just have one variable. And then this looks like some you can do u sub. And then this is going to eventually turn into one of those trig integrals. So then you just check your chart, because I don't remember those trig integrals off the top of my head. Trig integrals. Inverse trig integrals. It's the tan one? Okay. So the closest thing would be the tan one. Now, the one thing that you're missing to say that it's the tan one is you do need, like basically, first let's write this so it's a little bit more obvious. So this is u squared, and then this is square root of 10 squared du. Yeah, so this, the closest one that looks like it is the tan one, but then notice that you do need your a, so you need a square root 10 on the top, but that's fine, we can just make one. So you multiply the top by square root 10, and then you multiply the bottom by square root 10. So what you get is this, negative 1 over root 10, and then root 10 u squared plus then you write it like this. Then this thing becomes the integral, and then this is just the constant. So you just go from there. Okay, moving on. P is c squared and q is c3. Then you need to find this value. So the sum from the first term all the way to the 20th term. So we do have some formulas for that. The sum of 20 terms is I don't know. Well, if you know how your prof does it, then why are you asking me? Then 2, using the sum formula, u1, and then u1 is this, minus 20 minus 1 times d, which is log c q. I mean, these are just trig identities. But I don't... And then they're just there to help you get to here. So this is just like the end result. Okay, and then we need to find the value. So we're going to keep simplifying this, but we are going to do some substitutions. We know that this is c squared and q is c3. So this is c squared, and then this is c3. Hey Snakestar, how's it going? And then with this, we can actually just calculate everything out now. 20 divided by 2 is 10. There's a 2, and then log base c of c to the power of 2 is just 2. And then, so this is just 2, and then we have 19. And then likewise, log c of c to the power of 3 is just 3. You won a Pokemon tournament? What? Like the trading card game? Or like one of the video game ones? Pokemon mod? That wasn't even... How can you say that's Pokemon? That's Minecraft. Same thing? Can I pay you for private tutoring? No. Why don't you can feel free to ask a question, then I can help you out. But I don't want to do private tutoring anymore. I left that life behind me like 7 years ago when I became an actual full-time teacher. And now I just stream for fun. But like the cake, you can also join the Discord, and then there's a math help channel, so you can post there if you ever need help. I don't know how often I'll be checking it, but there is a teacher assistant in university that frequents there, and he'll help you out. And I still check in there every once in a while. There's an active community. Snakestar, are you on it? On there? Did you see? There's that one guy. His name was Devil or something. He joined. He asked one question about his IA. I answered it, and then he left the entire Discord. What the heck? Like, why don't you just stay on? That makes no sense if you need math help. Is he just gonna rejoin later then? I gotta say though, it's pretty dry right now. I thought there would be more people joining and then asking math help. And I even posted on the IB subreddit again. But you know what? I don't know. And it's so weird because like you go to the subreddit and like every day there's like 3 posts about people saying that they need help with math. I don't know. You can like give students like every resource that they could ever possibly need, and they're still gonna complain because I don't know. That's just what they do. Can't believe it though. It just dipped. Asked this question and then left. Yeah, see, notice right here. So I told you, I just Googled it. This is the final result. What your prof did is he just showed you how to get there with like showing all your work. So just go through it. He makes a substitution, and then he uses a trig identity, and then it simplifies into blah blah blah. Whether or not you need to know the substitution stuff, I don't know. That's up to you. How do you show work? You just copy this process. I mean, this is pretty clear. You just do the same thing with your numbers. Because it's the exact same question. You didn't get the answer? Then make sure you did every step properly. Because the only difference should just be numbers. Yeah. Why don't you just post your question, Jess? You still don't get the derivative? What? Still? Okay, what was the original question? I'll just scroll up. X to the power of 3 to the power of x. Okay. Okay, so we take the natural log of both sides, right? And then that means that on the left side, we can take down that exponent. Using log laws. And then we take the derivative of both sides, and then we're going to solve this implicitly. So the derivative of natural log, or natural log y, is 1 over y, and then we chain rule it with y prime. And then on the other side, this is a product, so we're going to use product rule. So the derivative of 3 to the power of x is, as we saw, natural log 3 times 3 to the power of x. And then this multiplies with just natural log x. And then we're going to add 3 to the power of x times the derivative of natural log x, which is just 1 over x. And then we multiply both sides by y to isolate y prime. And then, I don't know if you need to simplify this, but this should be your answer. I'll just write a bunch of brackets to be really explicit. And multiply by y. Y was the original question, so x to the power of 3 to the power of x. Hello, Max. How are you? I don't appreciate your mean words about the clips that I'm posting on my Discord. So in a pretty ugly format, but you know, if you're doing this on web work or whatever, it'll accept this. I don't think people are gonna post clips of me. Why don't we just make it YouTube clips? Funny clips. Why is my camera out of focus? What the heck? Who turned on my autofocus? I thought I turned that off. Yeah, autofocus is stupid, especially for a stream when you're not really moving. Anyways, Max, I'll probably mark your test by tomorrow, the end of tomorrow. I don't know when I'm gonna do it, but yeah. Don't delete it, just rename it. I don't know, funny clips or something. Because I think, you know, you gotta keep it separate from the meme channel, because that's just like meme pictures. And then the clips can just be funny YouTube clips. You gotta admit, that clip I posted was kind of funny. It was cringe? Yeah, that's why it's funny. You gotta embrace the cringe. Oh, and I also changed some of the rewards again. The timeout is now 10 grand. Just because, I don't know. I think it was still too abusable at whatever it was, 5k, 3k. So now it's 10k. And I still don't even know if that's a reasonable amount. Yeah. Cut off your ears? Ah, I was just gonna mention the life advice. No one ever has redeemed it so far. But best exam studying schedule? Okay, so for IB, my god, you just try your best, that's all. But I'm gonna tell you, you know, scientifically, at least from what I've heard, you know, cramming is not effective. I'm pretty sure they've done plenty of studies about that. Okay, go play Minecraft. Thanks for keeping it open. But like the most effective way to study is, you know, you do like a couple hours each day, like 1 to 2 hours. Because it's more about the continuous exposure repeatedly that will help you memorize things. And you know, I think it makes sense if you consider your brain like a muscle, right? There are people that just go into the gym once and then they just blast everything for like 3 hours, and then they think all of a sudden they're strong and they're healthy and they're buff. But that's not how you get strong. You have a consistent schedule and you work out like every other day or whatever. So consistency is the key. And you don't have to study for long amounts of times. That's kind of been proven to be ineffective. And like, I don't want to quote, say, countries that I've never learned in or taught in, but I have read anecdotes, so take it with a grain of salt. Like Japan, they have a terrible like high school system. they just cram all the time, and their scores are actually quite low because that's not the proper way to do it. They're just constantly stressed all the time, and it sucks. And then, at least from the person that I read this from, he was from the States and he knew how to properly study, which includes taking breaks and spacing things out, and they hated him because he got way better marks than they ever did, even though it seems like he did way less work. Because that's just how your brain works. Yeah, see? Jazz gets it once I explain it in terms of working out. You can't just go into the gym one day and then all of a sudden you're good. That's a grind every day. Honestly, yeah, of course it's gonna take consistency. Anything takes consistency. Although, what do they say? How many days does it take to build a habit? Like, or how many times does it take to do something before it becomes a habit? I think it's only a couple of weeks or something. I don't know. You can Google this stuff. But yeah. Yeah. 20 to 60 days. And what, your papers are in May, so you know, that's 20 to 60 days, so get started. I mean, you just paying attention to my streams is pretty decent enough, right? That's if you're paying attention to my streams. Now your other courses, I don't know, maybe if you're lucky you can find a English IB streamer on Twitch. But yes, thank you SnakeStar for the life advice. Or rather, redeeming for the life advice. Okay, I think we've entered into part B's. So Pablo drives to work. And then the probability he leaves before 7 is 3 out of 4. And then if he leaves home before 7, then the probability that he's late is 1 out of 8. Hello, I'm not 5 a.m. What's going on? And then if he leaves home at 7 or later, then the probability that he's late increases. And then we complete this diagram. So this is pretty straightforward. If it's 3/4 chance that he'll leave before 7, then that means that it's 1/4 chance that he'll leave after. And then this part is already filled out for you, and then we need to fill out these two. So it says here, if he leaves home before 7, right, before 7, then the probability that he's late is 1 out of 8. So the probability that he's late is 1 out of 8, which means that the probability that he's not late is 7 out of 8. But yeah, that life advice thing has been up for like a week and a half. And I didn't want to mention it because I just wanted someone to naturally use it, but I thought it would be pretty good. For those that have been in my class before, you guys know that I just talk randomly, and sometimes I say useful life advice. Okay, let's see. Find the probability that Pablo leaves home before 7 and he's also late for work. Okay, so that probability is just him leaving before 7 and then multiplying this by him being late if he leaves before 7. So 3 out of 32. Okay, find the probability that Pablo's late for work. So there's two instances where he's late, right? If he's late before he leaves, or he has a chance of being late if he leaves before 7, and he has a chance of being late if he leaves after 7. So the probability that he's late overall is the probability of these two branches together. So Let me do this other multiplication then. So if he leaves after 7 and he's late, so this is going to become 5 over 32. So this probability here is 5 over 32. So probability of him being late is 3 out of 32 and 5 out of 32, which is 8 out of 32. Which I think reduces, right? To 1 out of 4. Hey, just Ron, how's it going? Okay, then given that he's late for work, so now we know he's late, find the probability that he left home before 7. So this is a conditional probability question because, well, they've told you something that has happened. And we do have a conditional probability formula, but let's just say we want to find the probability of before 7 given that he's already late. So from the formula, right, it's the probability that he's late, and then over that is the probability of before 7 intersection late. And then this has been set up for you because both of these values you've calculated or found out in earlier questions. The probability that he leaves before 7 and he's still late is 3 out of 32. The probability that he's late overall, regardless of whether or not he leaves before or after 7, is 1 out of 4 or 8 out of 32. I'm going to use the 8 out of 32 just because the 32s will cancel out now. So 1 over 32 and 1 over 32 cancel out. So you're left with the probability 3 out of 8. Okay, then the next 2 days, Pablo will drive to work. Okay. Find the probability that he will be late at least once. Okay. Okay, so there's lots of ways to do this. You can use binomial cumulative distribution because essentially there's 2 days, right? So there's 2 trials. And then we have the probability of him being late, which is 1/4. And then we want to find out the probability that he's late at least once. So what we can say is we can say this. We're counting the number of lates he has, and we want this to be at least once. So x is our random variable, and then it's binomially distributed, and there's 2 trials, and the probability of him being late each trial is 1/4. Honestly, I probably wouldn't do it this way, but it is something that you can do. Of course, this is an upper boundary, or sorry, lower boundary, and we need to calculate upper boundaries, at least if you use a TI 8384. So this is the same as him being late at least once means that it's 1 minus him not being late. So this is pretty easy to calculate. You don't even need the calculator. So the probability of him not being late both days, well, we know the probability of him being late is here. So the probability of him not being late 2 days in a row is 3 out of 4 times the second day's not lateness, which is 3 out of 4. So this is 1 minus 9 over 16, which is 7 over 16. Okay, meanwhile, I have a big fat question about related rates. Suppose a police officer is half a mile south of an intersection. Okay, so here's an intersection. And then you got the popo. And then let me just call that y for now. So we know that this is 0.5. So any distances vertically are y, any horizontal ones are going to use the variable x. But okay, police officer is half a mile south of an intersection, and then he's driving north at 50 miles per hour. So what that means is that the rate of change of him moving north with respect to time is 50, positive 50. And then that means that the distance is negative 0.5 if we consider this to be the center. Okay. And then at the same time, another car, which is half mile east of the intersection, so second car here, so half a mile east, and this one's positive because this distance is to the right of the center. Distances are always positive, but this is, it has orientation. How do you define south versus north of an intersection? You need to start saying negatives and positives, right? 50 needs a direction. It's a rate of change. Is he going 50 north or 50 south? So you need positives and negatives. And then this person is driving east at an unknown speed. So we don't know this derivative. The officer's radar gun indicates 20 miles per hour when pointed at the other car. That is, the straight line distance between the officer and the car is increasing at a rate. So the police guy uses his radar gun and let's call this D for distance between the two cars. And then what they're noticing is, actually D is a little too, I'm gonna call it H because essentially it's the hypotenuse. I don't want to use D because it'll just be weird in just a second. Okay, and then it says the radar gun says that this distance, this guy's moving farther away, so the distance between the two cars is increasing at a rate of 20. And then the question says we need to find out this. So it's a related rates problem, so you need to relate all of these variables together. And then that's pretty straightforward to do because, the three rates or variables that you have, x, y, and h, are part of a right triangle, so we can relate them using Pythagoras. So our relation, and then this is the hardest part of related rates, is you coming up with the relation. H squared is equal to x squared plus y squared. And then once you have the relation, we just take the derivative, because we want to find out dx dt. So if I take the derivative of the whole thing, chain rule, each one is going to have, you take down the 2, and then you multiply by the derivative. So dh dt, 2x, dx dt, 2y, dy dt. And then now this is pretty easy because you actually know almost all of these values. You know this one, dh dt, you know x, you know y, and you know dy dt. And we're trying to solve this, so everything else needs to be numbers. However, there's one little thing, we don't quite know what h is, but that's easy enough. We can just use Pythagoras with our values of x and y to calculate h. And then from there, you can just solve dx dt as a variable using algebra, because everything else will be numbers. Does that make sense? Can I leave it at that for you to try out the rest? Yeah, the hardest part is making sure you have the right relation. And it's always helpful that you take inventory and you write down all the variables and all the rates of the variables. And again, the thing that you want to find, that means that every other variable needs to have value. So you'll need to, if you don't know something, you need to figure it out somehow. And then you just plug things in and then solve for the one thing that you're trying to find out, because everything else is just numbers. Okay, so then this one, honestly, I probably wouldn't do it like this in the middle of a test, just because the numbers are so small. You know, he's only going to work 2 times a week, so I would probably do it this way. The probability that he's late at least once is basically the probability that he's late once and then plus the probability that he's late both days. And then this is straightforward enough that I think this is how I would do it. First off, the probability that he's late both days is 1 out of 4 times another 1 out of 4, so he's late both days. And then him being late once means that one of the days he's late, the other day he is not late. But we don't know which day is the late day and which day is the whatever day, so we need to multiply this by 2. So, you know, first day is late, second day is late, plus first day is not late, second day is late. So then there's 2 of these. And you will probably get the same answer as this one. And then that's how I would probably do it, just because, again, the numbers were so small. Is Anita still in this chat? Did you figure out that question you're asking yet? Oh, no? Are you working on it still? Just follow the same steps. They're just different numbers. You went to eat dinner? Oh, okay, fine. Never mind. Okay, what is this? We have a cylinder. It has this volume. Express the height in terms of r. You got it wrong? How'd you get it wrong? Okay, well first off, you need to figure out this last variable h, right? So h squared is equal to negative 0.5 squared plus 0.5 squared. Do they tell you to keep things exact? Oh, I guess I shouldn't have used 0.5 because they literally said half. Okay, well let's just change these to half because maybe it wants an exact answer. Let me just color code stuff real quick. Okay. How many recorded lessons are there going to be this week? I don't know, 3 maybe? Okay, so from this we get 1/4 plus 1/4. So this is 1/2. So then h is basically the square root of this, so 1/√2. Are they difficult? No. So here's my h. And then now I know every single value in here. You know if your brain can take any more? Before the break or just in general? Because if it's just in general, then you're in trouble. So what do we got? If we plug in all of our values now, we have 2. 1/√2. Well, you're gonna have to find a way to fit more in there. But if it's just for the break, before the break, the 3 lessons will be pretty straightforward and pretty easy. 2 half dx dt, 2 half negative 1/2, and then 50. So then here's your equation, Jazz, and then you just solve this. So what do we got? We have 40/√2. We have dx dt. And then we have minus 50. So, I don't know. Why don't you just literally try saying 50 plus 40/√2? And, you know, if it's web work, it should accept this. Unless it wants it rationalized. But I don't think it cares. Okay, express h in terms of r. So our volume is pi r squared times h, and it tells us the volume is 20 pi. So from here, this basically means that 20 is r squared times h. So h is 20/r squared. The pi's just cancel out. So here's my expression for h in terms of r. And then materials of the base, top, and bottom cost 10 cents. And then the wall represents this. The total cost of the material is in cents C, and then show that the total cost is this. Okay, so this is easy enough to do. So the cost is, again, equal to 2 of the circles, 2 of the cost of the circles, plus the cost of the wall. Okay, so the area of the circle is pi r squared. And then the cost of that area is 10 cents, right? Per unit. So I take the area, I multiply by 10, and then I multiply by 2 because there's a top and a bottom. And then the cost of the cylindrical wall is 8 cents. Now, what's the area of this? Well, this is some stuff that you should have remembered from, you know, your basic geometries, but this is the circumference of the circle, which is 2 pi r. And then, of course, this is the height of the circle, which is h. And the wall is essentially just a rectangle that you roll up with the length being 2 pi r and then the width being h, or whatever you want to call it. So this area is 2 pi r times h, and then h in part A we figured out was whatever this was, 20 over r squared. So then this becomes 40 pi over r once you multiply them together. So that's the area of the wall. And then if you continue simplifying, I'm sure you get something like this. Yeah. 2 times 10 is 20. And then 8 times 40 is 320. And you see, now you're done. Easy peasy. Yeah, related rates problems are hard. Draw a picture, make a list of all the variables, and then find the relationship between all the variables, figure out any missing variables, and then finally plug them all in and then solve for whatever they want you to solve. So have you given this a try before you asked me? Yeah, you might have messed up your drawing. You did try it? Okay, let's see. A street light is at the top of a pole. And then a 5.4 foot tall man walks away from the pole at a certain speed. And then how fast is the tip of his shadow moving when he is 45 feet from the pole? Okay. So you have your pole here. That's 10.5 feet. And then it shines a light. And then along the ground, you have a man. And this man is what, 5.4 feet tall. And then the light shines down and then creates a shadow. And then we want to find out how fast this tip is moving. And we know some other things. We know the speed of the man walking. Okay. So when he walks further away, then the angle gets like steeper. And then basically the farther he walks away, the faster this like tip of the shadow stretches out. So that's why you just can't say that these two are the same. You can just think about that in real life, right? Okay, so how do we figure this out? So here, I'm gonna call this y, and then dy by dt is the rate at which y changes. But because this is just the lamppost street light, it's not changing length. So we can say that this is 0. And then we know that the speed at which this person is moving which I'm going to call dx dt, this is 4 feet per second, so 4. So if this represents the speed of x, then what does the distance x represent in the diagram? Because that's important. The distance x represents, well, from the lamppost to the person. And then similarly, let me change colors. Let me reboot. The rate that the shadow's moving, I guess I'll call it ds. This is what we want to find out. And then the variable s represents this distance, the length of the shadow. So this is s. And then we have one more variable, which is the height of the person. And the height of the person does not change, so this is 0. So now this is our setup. And then how fast is the tip of the shadow moving when he's 45 feet from the pole? Okay, so we also know x is 45 feet. Okay, so now how can we relate these 4 variables together? And then that might be the tricky part. 49. Okay, and we're going to use something that you might not have used in a while, which is similar triangles. The big triangle is similar to the little triangle. So what that means is that if I take Actually, let me just write it, draw it out here. So this is y, and then this is the height of the person, this is the length of the shadow, and then this is x plus the length of the shadow. We know that they're similar because they share the same angles at all times. So if I divide, you know, opposite over adjacent for both triangles, it should equal the same amount. Or if I take any ratio of any corresponding sides, it'll be equal. But let's just do that one for now. Or actually, ultimately we want s's. So why don't we take small bottom side and divide by large bottom side. So I have s over x plus s. This is equal to small vertical side divided by large vertical side. And honestly, I don't know if this is the best setup. So maybe we'll change it to a different ratio. Or you know what? Instead of doing quotients, I hate quotients. Let's change this to a product. So then this says s times y is equal to h times x plus s. Okay, and then now we can take the derivative of this. Now, remember, each one of these is a function of time. So first we're going to need to do a product rule and also a chain rule, if we need a chain rule. So by product rule, this is the derivative of s times y plus s times the derivative of y and then likewise over here we have a product, so the derivative of h times this, and then plus h times the derivative of the x plus s, which we can just take the derivative of each of these separately. Okay, and then you see the thing we want to solve pops up, which means that you should have every other thing, you should have the value of every other thing here. And if you don't have it, then you need to figure it out. So the only thing that we're missing is s, actually. So go figure that out. And you can just use this initial relationship to figure out s, or whatever you want. And then you should have all of these values accounted for. You plug them all in, simplify, and then solve for what you actually want. So again, the hardest part is finding the relationship itself. In this case, it was similar triangles. So go from there. Okay, back to this one. Finishing off, now we need to find a minimum. And find this minimum in terms of pi. Okay, so a minimum means we are going to optimize this. And because this is a calculator question, you kind of got it, but the fraction isn't the same. The bottom pick is the answer. Okay, so let's go through this. You complete the square. This is your x. This is your a. Well, this is your a squared, technically. And then you make a substitution. So you do u is equal to root 10 tan theta. So then du is root tan secant squared d theta. So then this you do a u sub and then you do another sub. Okay. Becomes this. So from your identity, you'll get this. And then over here, you guys can't see. Open. But solving for theta, you get this stuff here. Okay. Okay, so you make your u sub. And then you make your theta sub. Yeah, your du sub went wrong here. Because to substitute du, right? Oh wait, never mind. I don't think your u sub is wrong. Anyways, okay, let's keep going then. I think it's okay, actually. So then this one, and then this one. Okay, then you can factor out a 10 from the bottom, yeah. Factor out the root 10 from the top. This one becomes secant, these cancel out, so then you get d theta. So that just becomes theta. And then theta is inverse. And then the answer should be this instead. 1 over root 10. Yeah. You have the same answer. Root 10 over 10 is 1 over root 10. If you simplify this, this turns into this. How? Because that's how square roots work. If you take a square root and then you divide by the actual squared number, then you get the other square root. Like think about 5 over 25, right? That reduces into 1 over 5. Go review square roots. Okay, if this is truly a paper 2, then if we want to optimize this, we can just graph the function. It doesn't matter. It's just some people don't care. That's just how you write it. It's not like your answer is wrong. It's just written differently. Okay, so I'm gonna graph this then. So this is 20 pi and then r squared, which I'm gonna call x, plus 320 pi over x. And then this graph looks not so nice. Lame. Okay, then I guess we'll have to do this manually. So to optimize, we're going to take the derivative and then solve for r. So taking the derivative, bring down the 2, subtract 1. This is r to the power negative 1, so we bring down the negative 1, and then we subtract 1, so it becomes negative 2. And then this is going to be equal to 0. And then to solve for r, we just multiply everything by r squared. Or maybe I can just put this into the graph and then see where it's equal to 0. I don't know. It's just this paper so far isn't super heavy on the calculator, which I like, but okay, let me change the window. There it is. Okay. So as you can see from the graph, my derivative is equal to 0 when the radius is 2. Now I'm curious if I just change the scale, if I could just figure it out from the actual function. So let me just try that out real quick. 20 x squared x plus. Okay. So here's the graph of the actual volume of the function. Of course, we don't need to consider negative values because that would be negative radiuses, radii. And then Desmos can find the minimum, which is, again, radius of 2. And it even gives you the volume. It's 240 pi. So then we're done. Okay, so all I had to do was just play around with the scale of my graph. And then here's the last one, and then I am done. So Jazz, you better get your questions in soon. And this one doesn't seem like this will take me too long. Okay, we have a function, and then the line, a line, has this equation, and we know that it's tangent to the graph at 2. So write down the derivative at 2. So this is the slope of the tangent line at the x value 2, and luckily we already know the equation of the tangent line, so this is the slope of the tangent line. So this is just 3. Now find f at 2. So this is the value of the function at 2. And then this one is less obvious, but again, just think about it. Let's say you have a function. And then here's 2. You got it wrong twice. And then here's your line. So the issue of finding the function, if you plug in, like it's saying plug in 2 into the function, but you have no idea what the function is. But luckily we can find out the value using the equation, because the y value of the line is the y value of the line at the x value is the same as the actual value of the function at the x value. So what I'm going to do is I'm just going to plug in 2 as my x value into the linear equation. So this is just 7. You got it wrong twice. Okay, so you need to find S, right? So let's see, to find S, h plus 5 over 4, 10.5. Right? So we have this, and then we need to solve S. So we're going to go through the same thing. I need to multiply that 49 plus S over here. And then we're just solving for S, so, you know, algebra, simplify first, collect my S's, and then get S. So I have S is equal to, is 5.4 divided by 10.5 a nice number? No, it's not. Okay, so I'm gonna keep it like that. So 49 times 5.4 over 10.5 plus 5.4 over 10.5 S. I guess these brackets don't do anything. And then we continue solving for S, so then this goes to the other side. And then when you factor out the S, then you get 1 minus 5.4 over 10.5. And then on this side, you have 49 times 5.4 over 10.5. So S is this thing divided by this thing. Okay, these fractions are really bugging me. So I'm gonna get rid of the decimal, because honestly, you shouldn't be mixing decimals and fractions anyways. I'm just gonna move the decimal place over so that this looks nicer. And then 1 minus 54 over 105. What's 105 minus 54? 51. So on the bottom, this is 51 over 105. Are you following me, Jazz? I'm kind of skipping some steps here and there. The 105s, this 1 over 105, and then this 1 over 105 will cancel out. So you're left with a slightly nicer fraction for S. So S is 49 times 54 over 51, and then this is going to be some nice, well, not so nice, but it's going to be a fraction. And then I'm not going to use a decimal just because 2646 over 51. Oh boy. Okay, so then this is good. And then let's plug in values. So this one goes away because dy dt is 0. This one goes away because dh dt is 0. So what are we left with? We're left with 10.5 ds dt, which is this one. And then over on the other side, oh, we didn't even need to calculate s. And then over on this side we have h, which is the height of the person, 5.4. Dx dt is 4. And then we have ds dt. So notice all of the things that had s go away. I guess we should have checked that first before we needed to calculate s. And then this is pretty simple. You just solve for ds dt, right? Multiply the 5.4 in. Collect your ds's dt's, factor it out, divide over what was the other thing, and then you get your answer. Okay, then let g of x be f of x squared plus 1, and then p is going to be the point on the graph of g where x is 1, and then show that the graph g has a gradient of 6 at p. Okay, we will revisit this because I have another question. Is that math 155 stuff? But it's not working? Find the general solution to this. Express the solution explicitly as a function of the independent variable. Don't you need to use like fancy integration techniques? Like separation of variables or something? And then you take the integral of both sides? How do you do the integral on the x side? Is it partial fractions? No, you just divide through the x squared and then you're going to get some pretty easy terms. So what do we got? X squared dw dx. And then over here we have what? Root w something. I thought you were taking it this semester, Jenny. Okay, separate variables. Oh, you dropped it. Okay, so if we separate variables, then what happens is if I divide the root w over this side, and then on the other side, I divide the x squared, and then multiply the dx over like this. This you can just simplify. That's 8 over x plus 3 over x squared. So then you just integrate. So w to the negative 1/2 dw, and then integrate, 8x to the negative 1 plus 3x to the negative 2 dx. And then each one of these is easy to integrate. Well, actually, you have to be a little careful with this one, I think. The integral of 1 over x is natural log absolute value of x, I think. But okay, this one's easy, that one's easy, and this one's pretty straightforward. And then go from there. Okay, Jenny's still getting this wrong. Or not Jenny, Jazz. So what, 10.5 ds dt, and then over here, what is this, 21.6 plus 5.4 ds dt. So then you have 10.5 ds dt minus 5.4 ds dt is 21.6, which means that 5.1 ds dt is 21.6, so ds dt is 21.6 divided by 5.1, and then it says that this is wrong. Yeah, leave it as a fraction. I don't know, if you want to do 216 over 51. Try this one out. Because you're technically not wrong if you put in a decimal. If that's what you've been doing. Or technically you are wrong if you put in the rounded decimal. Both are wrong? Okay, let's start from the top again. Flagpole, 10.5. Its rate is not changing. Height of the person, 5.4. They're not growing or shrinking. The distance away from the flagpole is 49. And we know that the person is moving 4. Let me scroll up to the question. Okay, and then we want to find out how fast this is moving, which is ds dt. And then this is s. And then through similar triangles, s divided by x plus s is equal to h divided by y. So then that's what I have right here. And then I can multiply, cross multiply to get this thingy. Take the derivative, so derivative of s times y plus s times the derivative of y, and then dy dt is 0, so this goes away. And then likewise over here, dh dt times x plus s, this goes away because this is 0, and then h times dx dt ds dt. And then this is 10.5, this is 5.4, this is 4, and this is ds dt. Anyways, let me think about this. What do you want, Jenny? Let's see what Google has to say. That is not Google. Okay. What was it? Streetlight? Streetlight. And then person walking away. Rate of shadow. And calculus. Oh look, there's a YouTube video about it. Okay, so from what I gather, we made a little error in what S represents. So let's just get rid of all of this. Okay, so we made a mistake about what S represents. Notice that the rate that the person is moving, right? This 4 represents this total distance, or that's related to this variable x right here. So it makes sense that the shadow, the ds dt, should be related to this distance for s. So this should have been s. I think that changes our setup a little bit. So from our similar triangles then, this should be s here. And then the little length right here is s minus x. And then this kind of makes sense, right? The speed that this is moving is basically the rate of change of the total distance, not this little piece. So this total thing. So now, if we're using similar triangles still, it should be this instead, which is going to be rewritten as this, just because this is easier to take the derivative of. So derive. So you get, I'm going to use shorthand, so y prime plus y times s prime minus x prime. This is equal to s prime times h plus s times h prime. And then, you know, y prime and h primes are zeros. So similarly, this cancels out. And this one cancels out. So we still have this setup where we actually don't need to know what s is. But this is what, 10.5? And then ds dt minus x prime, which is 4. And then again, ds dt times h on the right side. So I think this is the right answer now. My bad, I set you up wrong. Yeah, so from here. Yeah, check isn't bad. Especially when you're like really desperate. But there were those There are those kids from our local prestigious university that got in trouble because they used Chegg on the final exam. Because Chegg actually sells its data to universities for a price, and then it checks traffic during the hours of exam time. And then it'll sell the IPs that have accessed it, and then if they're local IPs, they can cross-list it with, you know, the IPs that access the test online, and then you get screwed. Yeah, they also upload checkbait, right? Okay, so if I want to find the gradient of g, right, then I need to take g prime. So according to this, right, this is the derivative of f at x squared plus 1, and then this is a very subtle chain rule, essentially. You need to then multiply this by the chain rule of x squared plus 1, which is 2x. Okay, I'm listening to a relaxing Nintendo playlist, and then I think this song is literally just the GameCube menu. This is really weird. So please be careful with the chain rule. So then now, the gradient at x equals 1 is f prime at 2, if I plug in 1 into my x value, times 2. And then we know that this is 3, so then this is 6, as shown. And then let L2 be a tangent to the graph at point P, then L1 intersects L2 at the point Q, and then find the y-coordinate of Q. Okay, so first, let's find the equation for L2. We do know the slope, but we need a point on... We need the point where it's tangent. I have the x value, x, but I need the g value, so g of 1 is f of 2. Luckily, we found that out as 7. So line 2 can be written as y minus 7 equals 6 times x minus 1. This is just a point slope equation, because I know the point is 1 and 7. Okay, and then L1 is going to intersect L2, so y is equal to 3x plus 1. So here are my two lines, and then I essentially just solve this system. Oh, wait a minute. This is a calculator too. I don't even need to do that. Let me just graph both of these and get this over with. So y equals to 3x plus 1, and then let me reset. Reset my grid. So there's 3x plus 1, and then y minus 7 equals to 6x minus 1. So there's my intersection at 0 and 1. Yeah, Desmos, so useful. Find the y-coordinate of point Q. Well, the y-coordinate is just 1. So I guess I'll just say y equals 1. And I think with that I'm done, right? Yeah. Excellent. Now it's time to check my answers. Will I get a perfect score? I don't think I've ever gotten one yet, sadly. But this one was pretty straightforward. Honestly, I only lose marks because I didn't read the question and then, like, I didn't answer it. Or there was a stupid mistake for SL exam. I mean, it's always a 7, but I don't think I've gotten a perfect score yet. Okay, I skipped the first one because it's vectors and that's no longer part of the curriculum. And then... Good thing. Oh shoot, wait, what? I've been doing a paper 1 this whole time? Oh shoot, I've been using a calculator. No wonder this seemed like I didn't need a calculator. Well, now this feels bad. I knew this seemed too easy. Did I get a perfect score? Who knows? But I cheated. Wait, what the heck is going on? Oh my gosh. Time zone 2. Did you get a perfect score? I don't know. I better. Okay, I skipped the first one because this is vectors, and that's out of the curriculum. But then this isn't the same question that I did. What is going on? What paper was I even doing? It was not this one. Yeah, it was this one. Oh wait, okay, this is question 1, but it's from a different paper. This is question 2, which matches up with this one. Okay. So let me quickly go through this answer key and then help out Jazz. So 2x cubed minus 3 over 2 plus c, so that's the same. Blah blah blah, 19 over 2, that's the same as 9.5. I kind of cheated and used the calculator, but whatever. Easy enough to do. You take your integral and then you just plug in your lower boundary as 1 and your upper boundary as 2 and use fundamental theorem of calculus. You'll get 19 over 2, which is the same as 9.5. So sure, I'll just take that. N is 40? Yeah, 40. So that's good. 200, 200, 900, 900. So that's good. R is 4 centimeters, 4 centimeters. I got the graph over there. And then find the value of A and B, -2 and 1, -2 and, well, -2 and -1. So that's good. This one is a showing thing, so if you can show it, it's right. So I did, so that's fine. Okay, show D is log CQ, which I did, that's fine. And then I got negative 530. And this one I'm worried about, because I feel like I did this one wrong. Yeah, they got 610. So where did I go wrong? Oh. Wait, what? Why did I do this? Shoot. I didn't even use I didn't write down the formula, right? This is supposed to be a plus. And I put a minus. If I had added, everything would have been correct. Well, there goes my perfect score. 610. Okay, continuing the tree, 1/8, 7/8, 1/4, so those are all fine. 3/32, 3/32, 8/32, 8/32, 3/8, 3/8, 7/16, 7/16, 20/r², 20/r². Part B is a showing, so if you can show it, you did it, so that's fine. Find the minimum, it's at 240 pi. 240 pi, I cheated and used the GDC. So this is actually straightforward to solve for R. And then once you find R, you just plug R into the original formula and simplify, and you'll get 240 pi. Okay, and then this is the last question, right? So 3, 7, 3, 7, that's good. And then these are a show, so I showed that it was 6, so that's fine. And then the last one I cheated and I used the graphing calculator. But this is a very straightforward system to solve, but you solve for y and you get 1. One stupid mistake. I mean, I would still get a 7 for this paper, but still, that sucks. Why did I even write a minus instead of a plus? Okay, let's help out Jazz. Is this the second last question? So what do we got? 2x squared minus 6xp plus 50p squared is equal to this. And then if the price is increasing at a rate of $2 per month, when the price is $10, find the rate of change of demand. What? Is this all they told you? Huh? Does X represent demand? And then P is price, right? Wait, what's so hard about this question? So the change in the price, right, is increasing at a rate of $2. And the price is $10. And then we want to find out the rate of change of the demand. So we want to find out dx dt. Now, before you find that out, you need to figure out x. So that's easy enough to do because you know P is 10, so you can plug it into these and then solve for x. And then you take the derivatives and then you plug everything in and then you solve for dx dt. So why don't I leave the rest to you, because that's pretty straightforward, I think. Yeah. Congrats, another assignment down. Why don't we just wait for a bit? Make sure that you actually get the right answer. Meanwhile, okay, I was thinking really hard because I was stuck at that Baba is you one, at that Baba is you stage, and I think I figured it out. It was this stupid lake one. Okay, this is the issue here. I need to break the lake so that I can come inside and then push the wind out. So I make an exit for the wind and then I enter and then push it out. And then I can just make a sentence somewhere. Did you play this, Honeykey? Now, this is the issue here. From the words that I have, right? What I can do is I can make the sentence, like, for example, Key is me and Baba. Now, the issue here is, when I do that, neither of them are open anymore, so I can't explode the water. Because, like, as it is right now, right? It says here water is stop and close, and then I am whatever, Bob is me, and then I'm open. So if I'm open and then I run into something closed, then I open it, but then I die. So then this was the issue here. I had to find a way. No, I'm reasoning this out. I think I have this. I had to find a way so that I can control both the key and the Baba and have it be open. But that's the issue, right? I need to use this word and if I want to make key and Baba is you. But then I can't have it be open. So then I thought about this really hard. And then I totally forgot that I can do this. I can say that if I say Baba is you and key, oops, and then I die. Oops, hold on. I need to rethink this, because then this was the plan. I create two of the same object, because then I can be then the word and can be used to be the double object. Like I can say like whatever is me, and then I'm the double object, and I'm open. So instead of being like two different objects, because that uses up the word and, I make two objects, and then that opens up the word and to create an open. Then I can open this up. You guys see what I'm trying to say? Shoot, I thought this would work. So now, I think I'm on the right path though. That's what I gotta do. But how do I do that? I don't want a hint. I think I'm really close. Doing homework is as hard as this puzzle? Okay, what if... Oh, I think I have it. So first... Okay, you guys can't see it. Well, let me turn off my camera for just a second. Actually, well, this will exit the screen. But there's a flag right behind this corner. And you can see the word flag on top of it. So, I think... I say flag is key, now I have two keys. There was a flag right behind this corner in my camera, and then now I have two keys. So then this deals with my double issue thing. And then if I say key is you, now I'm the double keys. And then notice that the key is me and I'm open, which solved the problem. So now, boom, I made the exit for the win, and then I can push the win out. And then all I need to do is just finish this stage off by saying key is you and win, which means that I am win. Yeah. Oh my god, I've been stuck on that one for so long. Yeah. Okay, let's try this one. Isn't this the same stage? Hold on. What? What's the difference? One less opening. Oh. So does that mean I somehow need to triple up? Instead of being two keys, I need to make three of the same object? Okay, let me think about this. I feel like it's a similar approach. I need to control three of the same object. So I need to make the key, the flag, and Baba all the same thing. So what happens? So first let's just do what we did last time. And let's turn the flag into a key. So now I have two keys, and then if I can somehow turn both those keys into a Baba, or turn Baba into a key, then I think I have it. Oops. So let me just move these words out of the way. I might be able to use them later, I don't know. Okay, how do I do this? So why don't I become the keys? And then I can make game music loud. How about now? Okay, I think I got this. Easy peasy. Okay, then hello, Tofu Char. Okay, I need to turn Baba into a key. Baba is key. Uh-oh, how do I do that? Move the words out of the way? Hold on. How can I reasonably make Baba is key without breaking the sentence key is me? Does that matter? I guess it doesn't matter. What if I say key is you and Baba? Oh, but then I die. Because there are no longer any keys. But I think this is the right path. Move it out of the way first. What is it? Okay, I don't think I'm wrong in first changing the flag into a key, so now I have double key. Oh, I see what you mean. Do I know what you mean? Hold on. Okay, let's become the key. I think I need 3 though, right? I can't just sacrifice a key right now, can I? I have no idea what you're saying, honey key. Move these blocks out of the way? Okay, and then what? Break it now? Yeah. Wait a minute. But now what? I feel like you're supposed to make 3 of yourself. Jazz, did you finish? Okay, double key. Sacrifice key for second opening and then use Baba to push it out. But you see, I only control the 2 keys. So if I use both the keys, then I die. Because Baba is not me when I'm the keys. And that's why I want like 3 of myself. So, Key and Baba's you? Oh, you're done? Congrats. Make Baba's you and Key? Yeah, but if Baba is you and Key, then I'm no longer and open, so then I can't open up the water. You move the and into the exit so it's right beside the win. Yeah. I mean, you can do that, but then is shift Bob is you down. So it forms is open and win. So I'm key. And then I put the and in here. And do open is, oh, I see. And then Baba becomes the winner. Nice. So, didn't need 3 of myself then. All right. I finished the stage that I was stuck on for a very long time. Jazz has done her assignment. So I think I'm going to call it there for our Sunday stream. Oh man, clones. Did anyone watch WandaVision? The finale? Or watch that Christian Bale magician movie called The Prestige. So before I sign off, if you haven't watched The Prestige, I do recommend it, so I won't spoil it, but it has to do with clones, I think. I don't even know if that's a spoiler, to be honest. Well, if you haven't watched it, then you weren't gonna, so I'm just gonna, okay. I probably shouldn't spoil any of these shows, but there's the, there's like this famous philosophical debate, which I've mentioned to my class before, called the Ship of Theseus or whatever. Where like, if you have a ship, right, and then you sail around the world, and then it gets damaged and broken, so then you decide to repair it. So, you know, every couple voyages you replace a piece of wood there, a plank there, a sail here, a rope there. And let's say that, you know, after some time, you've replaced every single part of the ship. Is that still considered the same ship as the original one that at the beginning? So that's part 1. And then part 2 is, well, if you take all of those busted pieces and then you rebuild from those pieces another ship, is that one considered the original ship? So, I don't know. I thought that was interesting because, you know, we had the clones of the keys. So which was the original key? Yeah, something to think about. Are both of them the ship? Who knows? Anyways, with that, give it some thought, and I'm gonna sign off. So, see you guys later. Don't stay up too late. Bye, everybody.